Welcome everyone to this lecture series of Microprocessor 885. From today's video till next 6 to 7 videos we will discuss about 885 programming. Obviously you are learning this subject to learn how to code or how to instruct the MUP to perform certain tasks. So 885 is invented in 1970s, right? So back then there was nothing called secondary memory, only there was RAM, the primary memory. It was of 64 KB, we know that. So then the registers which were inbuilt within the microprocessors, we will know that how those registers and memory was used to program in 885. And here we are using assembly language, which is a middle level language. There are some mnemonics and also some computer understandable code. So see, in programming there are various instructions. So basically in 885 there are 5 groups: the data transfer group, address, branching and all, total 5. In today's video we will learn about data transfer group. By the name you obviously got to understand that this is, in this instructions we will only know that how data is being transferred within the register or with the memory and all. But before I start this video, I just want to make this point very clear that go and do watch the video on addressing mode. This is on my playlist of COA lecture series. There I've already make a video on addressing modes. If you don't know the addressing modes, I don't think that this video will become, you can't just take the full taste of it. So first, before you watch this video, understand addressing modes in the COA lecture series in my channel, then come to this video. There are 16, so let's start, There are 16 instructions for data transfer in 885. Before I start the main instructions, let's just make some points clear. Like, you know that in 885 there are 6 general purpose register: BC, DA, HL, and the other useful registers are accumulator, temporary register, which is not your use, it is used by the processor. And when we do programming, the value is temporarily stored at temporary register. I'm sure you have watched the architecture video. And there WZ, which is only used when some specific operations are needed to be performed. And the special purpose register like PC, SP. PC is, what does PC do? PC gives the address for the instruction need to execute next. And SP is stack pointer. What is stack pointer? Stack pointer holds the address of the top of the stack. Suppose this is my stack, that this is 0000, 0001, 0002. What will SP do? SP will hold the address of 0000. And obviously SP is of 16-bit. SP, PC, they all are 16-bit register as the whole address. And if you see the addressing mode video, you will obviously know. But though I have to say, whenever you see our instruction, first check the number. So suppose MVI B, 25. Just listen this very carefully. Till the last program you will learn in your life, don't forget this. First check the number. Okay, done. Then check, is there any I? If there is a I, then just get this very immediate in your head that this is immediate addressing mode, which means that this number is a data. And as there is I will say this on next point. So first number, second I. If there is I, this means that this is a data. If there is no I, this means that is a address. Obviously only these two combinations are possible, right? Either address or data. Next thing, check for a X. Suppose LXI H comma 4000H. First check the number. Oh, it's a 16-bit number. It can be either a data, it can be an address also. How can you understand? First, then check for I. So as it is an I, this means it is in data. This is not address. But how can a only register can hold a 16-bit data? Then check for X. X means register pair. I stands for I stands for data. X stands for register pair. So first check number, then I, then X. Obviously you will got to understand. And no, let's start. You will understand in the upcoming examples. So the first instruction that I will teach you is MPI register name comma data. MVI move immediate. There is an I, which means obviously there would be data, and there is no X, so it means it's a single register. What is its job? Suppose there is a data 15, and let's take an example. Suppose I have written MVI A comma 15. In every programming language, you know that first we write destination, then we do source. So it's left assignment, right? This instruction means assign the data in register pair. So 15 will be on A. Okay. Next, if we want to transfer a 16-bit data, suppose the data is 4000. You know that in memory, one address can only hold 1 byte data. 1 byte means 8 bit. So it's a 4000 data, which means it's a data, right? Let me change my instruction, otherwise it will confuse you. So first, it's a 4000 data, which means that I need 2 addresses to get the data. How do you know? Lower bit, lower address, higher bit, higher address. What does that mean? Okay, I will teach you. We know our registers, right? They are assigned like, suppose this is B, C, D and E. If we arrange it, how it will be arranged? 1, 2, 3, 4. B, C, D, E, which means B will get the higher byte data and C will get the lower byte data. Same goes with for any other instruction you learn in your life. Always remember this rule: higher byte higher address, lower byte lower address. So 00000001. First, higher byte, lower byte. Higher byte will go to this, lower byte will go to this. Now, LXI register pair comma data. This is the syntax I have shown. Okay, the main example is like this: LXI D comma 2500. What have I taught? First, you have to check the number. It's 2500. It's a 16-bit number. Okay, then I. Okay, there is an I, which means that this is a data. So transfer this data 2500 to a register pair. Now, if we write this D, it will automatically signify that this is DE. D will get the higher byte 25, E will get the lower byte 00. Okay, so what is MVI does? MVI will move immediate the data in a register, and LXI will move a 16-bit data in a register pair. Now the next extension is MVI M,25H. M, this term is the most important, the most significant instruction tool in 885. M is basically memory location, which means the outside the MUP. The memory that we can use for, sorry for my bad handwriting, memory, the memory that is used outside the MUP for if you want to store more data. See, you know that there are only a handful of registers, so we can't store all our data in inside the register, so we need memory. Before jump into M, first you have to understand that M holds the data whose address is pointed by HL pair. Don't get confused. Let me simplify it. First, you have to initialize HL pair with a number. HL pair, there is an X. Okay. HL pair don't know that is it an address or is it a data. For him, it's just a number. So, I LXI H, 9000. What does that mean? H and L. H holds 90, L holds 00. 9000, it's a 16-bit number, which means it can be addressed to. What M understands? It will go to the memory. It will find a location 9000. Suppose this is here. Now 9000 holds a data called 12. MVI M, 25. This means go to address 9000. First, you have to understand what is the data inside HL. It's 9000. Go to memory. Find the location 9000. Now there is a data 12, but our instruction is you have to move 25 into M. So this 12 will get erased and 25 will get stored. Is it clear? Let's take another example. So if we want to use M, first we have to know what is inside HL. See, when HL can have values from 0000 to FFFF, and when we start to programming, if we use Jubin's stimulator, all is initialized with 0000. So they will hold this address 0000. Now, what M understands? M first check what is inside HL. Now it goes to memory. At memory, it finds the address located by HL 0000. Now, what data is there? It can read from there, or you can obviously write also. This is what M does. If you have watched the addressing mode video, then I don't need to repeat, but as there all the instructions are MVI A, 25H, LXIH, 2000H, MVI M, 10H. All of them had common one thing, that is I. This comes under immediate addressing mode. Why? Because data is given in the instruction already. Okay. Time for the next instruction, which is move. Move means data moving or copying, not cut the data. The syntax is move register name, register 1, register 2. This is the syntax, right? What does this instruction do? That move the data in register 2 to register 1. Suppose example, move B, C. This means the data which C holds, suppose 15, move the data to B. The data in C remains the same, but B simply copies the data of C. Clear? Next is move register comma M. Okay, let's draw. What does this instruction says? Move B comma M. Register name, whatever you can decide. I've taken B. First M. So there is something in HL pair. Let's say 2000. This is our memory. This is address 2000H. And there is something in our B register, suppose 10. What does this mean? First of all, whatever is in M, you have to move it to B. Right? See, you have to understand something. B is a register, so obviously it's a single register. It can't hold something of 16-bit, which means it can't hold an address. So this is it can be used to store some data. Now, from where the data I will get? Suppose in HL pair I have told you there is 2000 data. From HL pair 2000, the M gets 2000. It will come to memory, find the location 2000. Now there is a data something called 99. This means that the data stored at M will be copied to B. So now M was 99 and from now B was 10, it will become 99. Clear? Move register comma M means move the data from the memory location M, which address is given by HL pair. This simply copies it to B. Next is move M comma register, which is just the opposite of this. Here we have done move B comma M. Here you have to do move M comma B. Come on, answer it yourself. I will not help you. Do this with me, otherwise you will never get this. Whatever is in B, I have to copy that to M. Right? So, suppose B has 10, we need to send the data to M. But first, for that, I need M's, where this M is. I have to send the data at a particular address. Now, HL pair. First, you have to find HL pair. So, HL pair is 1000. So, go to memory. Find location 1000. Then, there is something or maybe not. You have to send the data 10 to 1000. This is what MOV or move instruction is used for. You have to notice one thing, that here the registers are given. Hence these three addressing modes are called register addressing modes. Okay. The seventh instruction is LDA. First, understand what the name means. LDA is accumulator, LD is load. Now, load accumulator means that we have to put on something in A. A is accumulator, which means it's a 8-bit register. So this means whatever you do, A will get the data. Now, if I had to put some data in A, I can easily write MVI A comma 23, isn't it? So this means that this instruction is slightly different. What does this mean? The syntax is LDA, suppose 9000H. When you see 9000, it's a 16-bit number. But A can only store 8 bits. So this means that this is not an address, this is not a data, then what is it? This instruction simplifies that in some memory location 9000 memory, in some memory location 9000 there is a data. What you have to do is get that data from 9000 to A. Okay, here is a trick to remember. This is a data, this is also data, but as it is 16-bit, we can say that it is an address. In these cases where you have to get the data from an address, then how it is being written like this, that LDA 9000, the mathematical term is like this, but when you need to understand, what you will do is A gets the data from the location 9000. Now don't get confused between M and this addressing mode, because AIM's addressing can be only pointed by HL pair. Okay, but in this case the address can be anything. Here no specific register or some specific address is needed. Second instruction is just an opposite of LDA, that is STA, which means store the accumulator. Means in this case we were loading the data in A. Here we will store the data from A to a particular memory location. So what is like the example? STA 5000 means whatever is in A will get stored at the memory location 5000, because obviously you know that only one memory location can hold 1 byte at a moment. Our accumulator stores only 1 byte, which is 8 bits. So the data in accumulator will get stored in memory location 5000H. Clear? Next instruction is lhld. First, listen to the name carefully. lhld, load HL pair directly. First of all, this example is like this: lhld 1000H. 1000H means it's a 16-bit number, but there is no I, so this is not data. Or if I have to store 1000, then I can just simply write LXI H comma 1000, right? Then HL will get higher byte 10, lower byte 00. What lhld does, simply like accumulator, simply like LDA, but here the case is a little bit different. HL, which means that they can store 16-bit data, 8-bit here and 8-bit here. Then what is this 1000 is doing here? This is when in memory location this 1000, 1001. This instruction lhld address means first go to the address 1000, get the data, then go to the address incremented address, that is 1001, get the data 12. This is the higher address and this is the lower address. H is the higher bit, L is the lower bit. So what it will do, that load HL pair with the data from respectively 1000 and 10,000, 1001. Just let me say this again. Suppose in memory there is 5000 and there is 5000. Obviously it is continuous memory allocation, so there are data stored somewhere. What you have to do, get the data from these two separate locations in a register pair. So load lhld, then address 5000H, H and L 5000H, this address, data, and 5001's data. 5001 got 99, sorry, 5001, 5000, because higher address, right? And 5000 it will get, sorry, 99, and this will get 12, because H gets the higher address, 5001, L gets the lower address, which is 5000. So 5000 had 99, 5001 has 12. As LD and ST, there is also LHLD and SHLD. Store HL directly. What does this mean? That if I had something in HL pair like 10, 20, I want to store these two data respectively at two locations. How can I do that? In memory. So SHLD 1000H. This means there is this memory where is 1000H. First lower address 20 will get stored at 10,000 H. 10 will get stored at 1001. This is not address, this is data given by address. This is why we can write this as 10,000 H. These braces means that this is data given by address. Okay, so H gets from 1000 H, this gets from 1000 H, this is 1001 H. Clear? Now, as we are giving data through address, this is called direct addressing mode, because the address is being mentioned here, but through address we are giving data, so this is direct addressing mode. This is what I'm saying. Please do watch the addressing mode video, huh? The next instruction, LDAX register. Just a second before, we have seen LDA, STA, I'm sorry, LHLD, SHLD. Now, what is this new thing called LDAX? First, X means register pair, A means accumulator. Accumulator can only hold a 8-bit data. So, what is this called? Load accumulator from some register and all. Let's see. First, as it is X, which means that this is a register pair. Suppose BC. Okay, I have written this already. BC. Now BC holds some data, 20 and 00. So the syntax is LDAX B, only B. This is written like this. What can I do? I have to load A from B and C because it's a register pair. Okay, here I can only load 8-bit data, right? So what can I do? BC has 2000. This can be address too. Okay, go to memory, find the address 2000. Then there can be data stored at this location, suppose 37. This instruction signifies that load accumulator with the data whose address is given by a register pair. Don't get confused. LHLD signifies load HL pair with the data given by a address. Here the address is mentioned, but in this case they mentioned a register pair. From that register pair, the address we get, from the address the data we find, we have to put the data in A. So in 2000 there is 37. This means that from 2000 location 37, this data will get stored at A. Clear? Next instruction is STAX register pair. This is the opposite, obviously. So A has let's say 10, we have to put this data in a register pair. Let's say HL, okay? I've seen LDAX H. In HL, there is something called 4593. So this data can't be in this one of these register. How can you decide that in which register it will go? I like HL, I don't like HL. This is not something happens in microprocessor. It's completely logical. So 10 will get stored at a location pointed by HL pairs, storing numbers. In memory, they will go to 4593. Now this 10 will get stored at this location. Let's take another example. LDAX D means in A there is 12. D suppose have 9000. So go to memory, find location 9000, store the data that A have 12 to this memory location. Clear? Now in this case, what is happening is we are storing some data or like putting some data in accumulator from some registers. In those registers there is an address. Okay, we are actually storing the data or putting the data from the particular address. This is called indirect addressing mode. Address तो है पर registers registers are used. This is indirect addressing mode. Please do watch that addressing mode video, otherwise you will not understand. So these are the main instructions that are used. Now there are 4 more special instructions which are not usually used in programming. There are some special cases, but obviously I don't want to cheat on this subject. Be respectful and be sincere to it. Learn all of them. Maybe in some instruction or obviously in timing diagram you need them. The first instruction is PCHL. As the name suggests, PC and HL. See, this is the instruction is just written like this, nothing else. What kind of addressing mode is this? There is no address, there is no data, there is no register pair and all, only this. But just these 4 letters can make you understand the whole instruction, that what does it want to say. This is called, these 4 instructions belong to implied addressing mode. Means the meaning is hidden. So PCHL, PC is our program counter, HL is our register pair. This means that the value between these two can be exchanged. 9513 1234. After the operation gets performed, it will be 1234 9513. Now just being curious, I've already told this actually, how this is being performed. Like you do that, swap the variables and all. So there you use extra variable. Here we use WZ, right? The special registers, you remember? So what is actually happening? PCHL 9513 1234. First this is being stored at WZ. So WZ become 9513. Next this is being stored at HL. HL become, sorry, now the value HL will transfer to PC. So PC will 1234. And the value of WZ will now get transferred to HL. So it will become 9513. So value is being exchanged. But this instruction can be only performed in PCHL. Next, SPHL. What is SP? Stack pointer. What does a stack pointer do? It holds the address. It holds the address. Remember this. It holds the address of the top of the stack. So this is stack. These are the memory locations. Okay, there are some data. So SP will hold the top address. So SP has suppose 4000 NHL has something maybe 1000. After SPHL, it will become 1000 and 4000. The next instruction, XCHG, exchange. This instruction can only be performed on two particular register pair, that is HL and DE. After using this instruction, the value of HL will get transferred to DE and the value of DE will get transferred to HL. But just remember one thing, the instruction is only for HL and DE. Clear? The last instruction, XTHL. See, this is not something widely used or commonly used, but it's an excellent addressing mode as instruction. First of all, if we see the name XTHL, so HL pair is something, but X can be exchange and all. But what's the actually meaning? Okay, I will say you. This means exchange top with HL. Top means, okay, when you listen this word top, this may become something like stack. Stack top means stack pointer. Stack pointer holds the address of the top, right? Let's see. So this is SP, this is SP plus 1, SP plus 2. This is the top, right? Suppose this is stack. What it is used to do? Exchange top with HL. Remember, SP holds the address. So SP has 1000. If you are a like non-attentive student, what you will do, HL, you will think that this 10,000 will get exchanged with HL. Here SP is 1000, right? So by this instruction, it can be said that does it mean exchange top with HL means SP is a 16-bit register, so it has 16-bit value, then exchange the value with HL? No. What does this mean? SP holds an address. Go to the address, that is 10,000, which is here. There is a data. On 1001, there is another data. What is your task? 10,000 has 84. 10,001 has 13. After XTHL, the value stored at 1000, location 1000, will get exchanged to this, and the location, the data stored at the higher address, which is 10,001, will get stored at H. Which means XTHL, what it does is exchange the data of HL with the data which is pointed by stack pointer. I think I didn't make it complicated. Again, I will show you. Suppose 4000, 4001, 4002, unnecessary. 10, 20, 30. SP. What SP has? 4000. What is 4000? Top of the stack. Now, HL. HL has, suppose 1, 2, 3, 4. We perform an instruction XTHL. Oh, what we will do now? SP plus 1, the location 4000, location 4001, it has 20, it has 10. Here comes H and L. H and L has 1, 2, 3, 4. XTHL is performed. Now, these data will get transferred. So now what will happen? This comes here, this comes here, this goes to them. Sorry. 4000, 4001, H and L, 12, 34, 10, 20. Higher address, higher bit. So H gets the higher number, okay, because it's if we arrange it, this is something like this. So first comes HL. H will get 4000 data, which is 20, and this gets H data, which is 12, and they will exchange with each other 34, 10. Okay, so XTHL helps to exchange the data of HL with top of with the data pointed by top of the stack. Let's have a quick recap. MVI A, 25H, A will get the value 25, LXI H, 4000H, HL pair will get the value 4000H, MVI M, 25H, that which means M will get the value 25H. What is M? M holds the data pointed by HL pair. So now what you want to do, you want to store the data 25 at M, now which means that HL, suppose HL holds 101000, means in memory location 1000, M signifies to this location, I mean the location that HL pair points. M will store this data 25 at the location pointed by HL pair. Then move A, 25, move A, B, move B, C and all. Move M, data, move data, M, then LDA, STA, LDAX, STAX, LHLD, SHLD, and the 4 PCHL, XTHL, SP, just a minute, XTHL, XCHL, SPHL, PCHL. So I hope now all the addressing modes are clear to you. If there is any confusion, then ask me in the comment section, or you can email me. Thanks for watching.